lesson 6. So problem solving using trig ratios. We're going to talk a couple of word problems. We're going to talk about bearings, which is a little bit different. And just other kind of applied problem with trigonometry, okay? All right, so in this lesson, we used our knowledge of trigonometry to solve problems, including situations which more than one calculation is required to determine the solution to the problem. The illustrations in this lesson are not to scale, so that means that these aren't, don't take those for exact. Well, that doesn't look like 50, that doesn't look like 30. Okay, it tells you right off the bat they're just for demonstration, not for accuracy. Okay, so just going right to the example here. Example 1. Carmen is a surveyor who's using a transit to determine the height of a tree. Okay, the transit is placed 52 meters from the base of the tree, so that's what this distance is here. And the angle to the top of the tree is 12 degrees. Okay, so that's what that is there. If the transit stands 1.8 meters high, calculate the height of the tree to the nearest tenth of a meter. So how are we going to use the information they just gave us? What are we going to do with it? We can't use Pythagorean theorem. We only have one side. You have to have two. No, it's not going to be sine. Tan. You have angle, adjacent, and you want the opposite. Oh, yeah. There's just one little hiccup, is the transit is 1.8 meters off the ground. So, so when you get this answer, you have to add that 1.8. That's the only tricky part for that one, yep. So, as you guys are seeing, again, guys, trig, once you know it, I'm telling you, it clicks. It's super simple. So if you're like a little gray right now, I'm telling you, once you get it going, you're going to understand it. The first thing is, identify where your angle is. Second thing is, what trig ratio am I going to use? I want the opposite side, and I know the adjacent side. So you should be like OA, TOA. Okay, tangent. Tangent of 12 equals the tree over 52. Simply times 52 to both sides.
Junior class change.
That gives you 11.1. So 11.1 is this piece of the tree, and we have to add 1.8 to it for the part of the stand that's off the ground. That gives me 12.9. So the height of the tree is 12.9 meters. Not that bad, right? You just have to read. Okay, I don't mean that in a mean way. Okay, determine the angle of the base of the transit makes with the top of the tree. Answer the nearest degree. So it's asking, excuse me. It's asking for the base. Oh, so it's asking for if it was from here. So it's asking from the base of the transit what it makes from the top of the tree. So the transit's off the ground. So like if I was looking at the projector here, okay, this is not good for the video purposes, they can't see me, but if I look at the projector here, if I was standing straight up, and my angle to that would be, let's just say that's 30, right? But if I drop down, what's my angle have to change? If I have that same 30, I have to move my angle where? Yeah, back to get a bigger angle, right? Because I'm further to the ground. So we should expect B to be a bigger angle, is my point. Okay? So we're going for this angle here. Okay, so now we have the adjacent side. We have the opposite side. So we have to use inverse tan here. We're finding an angle. Remember, I said whenever you're finding an angle, you're going to be running into inverse trig. So this is what the setup would be. Tan of x degrees equals opposite over adjacent, so 12.9 over 52. .9 over 52. Can we please just take a second, pause for a second while you're writing things down? I want you to understand something. The ratio of opposite over adjacent, I really want you to understand we're going to get a pretty small degree still, and why are we getting a small degree measure? Yeah, the tree is 12.9 to the distance is 52. That's a pretty big gap. My opposite side, this tree is really small in terms of the triangle. Okay? The distance between the tree and the transit is really big because we know the hypotenuse will be even bigger because this is 90. Okay? So my point is just understand that this is a really small angle because it makes the really small side in comparison to the others. Okay? 12.8 to 52, that's a really small angle. Okay? So when you do that, we're going to go inverse tan now of 12.9 over 52. You get 14 degrees. You get 13. What 13 point what? 9, yes, around the nearest degree. But yep, you're right. Okay, any questions there? Okay. All right. Now we're going to get circles involved a bit. All right. A circle with center C as a radius of 20 millimeters is tangent to the arms of POQ. If the angle POQ is 50, determine the length of OC to the nearest millimeter. So we're trying to figure out this distance, OC, to the nearest millimeter. So does anybody see any pictures or any ways we can draw this that would help us? Yeah. Okay, so you're saying call these 25s? Okay. That's a good start. What else can we all understand right now, guys, we're doing trigonometry, so we're trying to make a what? We're trying to make a triangle. So how can I make a triangle that's going to help me here? That's what I'm asking you. C to Q and C to P. Okay, so good idea, Noah. But if I go C to Q and C to P, what kind of triangles do we want? Right, and we have no indication that those ones you'll make are right triangles. This one? To where?
Just straight down to the ground.
Like that? Okay, that's good. And there. That's correct. You make right triangles there. Now here's the thing that you may not know. A tangent line, a radius, this is actually in Math 9, we actually talked about it. A radius to a tangent line is perpendicular. So what that means is a tangent line is where it crosses one time. It hits at one spot. If you draw a radius to that, that's perpendicular to that line. So now why that helps us is because if that's a radius, we know the radius, don't we? It's 20. So now we have 20 and we have an angle from what Josie said, and we're good to go. Okay? So the part that you really probably forgot or don't know is a radius, okay, or radii if you want to use the plural. Radii to a tangent spot of a circle is perpendicular. Perpendicular means 90 degrees, which we want. Okay? Is that good? So now this is what we have. I'm going to draw this for you over here. We essentially have this picture here. That's what we have. I just kind of tilted it so you can just kind of see it. Which trig ratio are we going to use here? So, well, what are we finding again? We want to find OC. So we want the hypotenuse. So I'm using cosine or sine automatically, ca or so. Do I have opposite or do I have adjacent to the 25? So I'm using sine, correct? Sine of 25 is 20 over OC, which is what we're trying to find. OC is just the line segment there. This is OC right here. Any questions on that? So they're going to switch spots now, right? The thing I want's on the bottom, so I'm going to times this over and divide the sine 25 under. So these guys essentially switch spots. So you have OC. That's what you get. OC ends up being to the nearest a millimeter, 47. And you calculate that. 47 millimeters. Okay, questions? All right. Okay, I'm going to give you a second, and all I want you to do with this one, they already have the picture there for you. I want you to see just how far you can go, and when you get stuck, I'm going to ask you where we got stuck. I'm going to ask everybody in the class. I just want you to go through this, read this, see what you can get going, see what you're doing, and then just when you get stuck, you can just kind of stop and just know where you got stuck, okay? I'm going to pause the video. Okay, so if you got stuck at which ratio to use, guys, this is what I want you to understand. Let's go through this and put the information in first. In the diagram, the man on the ground is saying 12 feet from the wall. That's important. Okay, that means it's 12 feet right here. So we have 12. The angle of elevation from his eye level to the level of his wife in the building, up here, this is 62. So this is what I'm trying to explain to you is that we're trying to figure out the height of the building. So if the man's eye level is 6 feet from the ground, so let's label that. He's 6 feet. Okay, and his wife, his eye level is 5.2. This right here is 5.2 to the top of the building.
So you gotta add those up.
Right, how high is the building? So what we're going to do is, first, we need to figure out this side. We're figuring out that side of the building. How tall is that? Okay, well, if I look at it, this is what I was trying to explain to you guys. I want the opposite side. I'm given the adjacent side. The hypotenuse is irrelevant. So I know it's OA, which is TOA. So I'm doing tan 62 equals x over 12. That's just our normal trig setup. And we just times 12 over. So x ends up being 22.56. And then that's the height of the wall from his view. So we have to add 6 because of his height. And then we have to add her height of 5.2. Or not her height, but from her eyes to the top, which gives me 33, and they round it to 0.8. So 33.8 feet is the height of the building altogether. The tricky part is, don't forget to add his height and her distance from their eyes to the top, and then knowing which trig ratio. Okay? Now, in reality, what Joe said, I found the hypotenuse first, I used Pythagorean theorem to find that, that's fine. Just you're doing an extra step that you don't need to do, that's all. Okay? Because you find the hypotenuse when that's not relevant. Okay? Anything else before we talk about bearings? Yep, bearing directions. Okay. All right. We'll talk about these in Math 22, so it's not just a one-time thing. A bearing is an angle measured clockwise from the north direction. So this is used in directional. Okay? So the boat on a bearing of 40 degrees is written this way. So north, 40. Okay, so if you're just facing north and the boat is going 40 degrees, it'd be going that way. So essentially we'd be going, what's that, northeast? Okay. There is bearings that are more specific, and we'll talk about those. I think we just talked about those in Math 20. Yeah, we just kind of use this simple one here. So here are other bearings. So 150, so that'd be 150. So that would be 90 plus 60, so that's this direction. Essentially it's southeast. 225. Southwest, 330 northwest. Okay, so that's your bearings just in terms of degrees from north. So you start north and you do the degrees it says from that spot. Okay, so like what direction would 190 be? Southwest. It'd be right here. Okay, what direction would 45 be? Northeast, okay, and then 310. Northwest. North, south, north, no. Northwest, okay, northwest, all right. Okay, let's look at the problem here. It's our last problem. All right. Okay, a ship travels 6 kilometers from port B or P on a bearing of 120, the position Q to position Q as shown. The ship changes direction at Q and travels north until it reaches position R, okay, which is due east of P. So lots coming at you here. So what it's saying is it goes north, it's due east, so you can see what it's setting up. It's setting up a right triangle for you. So that spot I just put right here, this is where position R is. That's position R. How far east of P is the ship at position R? So how far, we're talking about this distance, right? We're trying to find that distance. Okay? What information do we know? We know this is 90, yeah. What else do we know? Yeah, Jose?
That you subtract 120 from 9 is 30.
You guys hear that? That's really important. She said this right here, that whole turn from N to Q was 120. Oh, sorry, lose my voice. And we cut that. What's 120 minus 90? 30, because we're cutting this piece out right here. So that's 30, that's 90 right here. Okay, well, if we have those two, we have the other ones. That means this is 60, right? What else do we know?
That the traveled 6 kilometers.
Right, we have everything we need. We can now do a trig ratio for PR. We're trying to find PR. We can do a lot of different ratios. Okay, I'm going to go ahead and go from the 30. Okay, so that is the hypotenuse, right? And this is the what? Adjacent. So I'm going ca. Cosine. Glad you guys are excited about that. So there it is, x over 6. Multiply 6 to both sides. The distance ends up being 5.2 kilometers. That's what this distance right there is. Any questions? Okay, let's keep going here. The ship continues to travel north further 12 kilometers to position S. Okay, so it goes 12. That's 12. To position S. Determine the bearing S from P. So what is this bearing? So the question, is the bearing this mark or that mark?
Second mark.
It's the first mark. Bearing's always from where? North. Yeah, tricky, right? So what we have to do is, okay, so how can we figure this out? Well, we know that this is 12. We know, oh, I already had 12 there. We know that's a right. What else do we know? Yeah, we know the side and the bottom. We just found that, didn't we? This is 5.2. So we can figure out this angle, and then it's going to be that minus 90 minus that to get this angle. Stay with me. We have these two sides. We're going to find this angle and subtract it from 90 to get that angle. That's my bearing because that's from north. You guys staying with me? Okay, so what we're going to do is that's definitely going to be opposite over adjacent. So I'm doing tan of x equals 12 over 5.2. I have to use tan inverse. Okay. When I do tan inverse, we get, yep, 67, which we take that, we minus 90 from that, or minus it from 90, and 23 is the bearing. That spot's 23 right there. Because those two angles should add to 90, which they do. All right, last question. If the ship maintains an average speed of 9 kilometers an hour throughout the journey, determine the nearest tenth of an hour, the time taken for the journey. So we know he's going from N to P to Q, then he's going just to R, and then he's going to S. And is he returning? Okay. So what pieces don't we have?
We don't have the distance.
Okay. All right, sorry, I'm going to erase this and we're going to start fresh here. Okay, and I'll do the work up here for C, guys. We'll do this as C right here, so we can use the picture. Okay, so let's highlight our track here. What did we find out? Yeah, we didn't find out N to P, did we? Yeah. Says if the ship maintains an average speed of 9 kilometers an hour throughout the journey, determine the nearest tenth of an hour, the time taken for the journey.
And N was part of the journey. No, it wasn't. It's just P to Q.
Oh, no, it is just P to Q. In the very beginning, it says that that's the position that he starts from. So it says the ship changed direction at Q and travels, the ship travels 6 kilometers from port P. Yeah, port P. The N is just north. So P is your port where you're starting. So Luke's right, so I can erase this here. Okay. So that's where we're traveling. We just have 3 pieces is all. Our 3 pieces are PQ, P to R, P to Q was 6, yeah. PQ plus QR plus RS, that's what we're adding up. Like Noah just said, that's 6. We know that's 6. Okay, how do we get QR? Pythagorean theorem, yep, we can do it. We have 5.2 and 6, so it'd be 6 squared minus 5.2 squared equals RQ squared. 2.9, so yeah, round to 3. Okay, so we got 3 there, that's good. And then RS, this guy. So we know that this guy, right here, this is 5.2. We know this one was 67, right? Yeah, we got R to S already?
Yes.
What do we get for R to S?
Well, it's 12 because it's in the
Oh, that's how far.
Yeah, it is.
R to Q, so it's 9.
No,
Did it go 12 more?
no, it went from
Did it go Q to S for 12? Yeah, so it says the ship continues traveling north further for 12 kilometers to position F, so that's correct. So this right here would be our 3 to 12 to 6. So your answer for part C would be 921 kilometers is the distance traveled for the journey. How long would that take then if he's traveling at 9 kilometers an hour? You divide that by 9, 2.3 hours. Okay. All right, that's good. Stop there.